We've been talking about this 700 mile per hour vehicle for the longest. I know I've done videos on it. What stage are we at now? Like, are we still in that stage where we're just talking about it? Or are we close to actually being able to see this thing in action, actually ride on it, all of that? You know, this vehicle that is pretty much faster than a Boeing 747 that Elon has coming. I'm ready to get out of the speculation phase. So let's check this video out and see where they are.
The team were assembling the world's longest full-width Hyperloop tube at 1,600 feet.
The main attraction of the Hyperloop system is its supersonic speed.
If you've been keeping up with the latest tech news, you've likely heard of Elon Musk. He's a major player in the technology world and is known for his out-of-the-box ideas.
Hyperloop. It's 3.5 times faster than Japan's Shinkansen bullet trains, even faster than a Boeing 747.
Recently, Musk has set his sights on an ambitious new project, a fifth mode of transportation. And no, this is not a prank. It's actually happening. This isn't just about adding another travel option. He aims to completely transform the way we travel. Musk's vision is a vehicle that could travel at speeds of up to 700 mph, which he claims would outpace a Boeing 747. In this video, let's talk about everything about this groundbreaking concept. We'll cover the origins of the Hyperloop, its potential, and the challenges it faces. So, without further ado, let's get started. Origins of the 700 mph Hyperloop. When most people hear Hyperloop, they think of it as a specific invention that Elon Musk proposed a few years ago. But in reality, it's more of a broad transportation category than a single fixed product.
This is the future of high-speed transportation. It's 3.5 times faster than Japan's Shinkansen bullet trains.
And the core idea is pretty fascinating. It proposes that a pod filled with passengers or cargo can zoom through a nearly airless tube at incredible speeds. Elon Musk first floated the idea of a fifth mode of transport called the Hyperloop back in July 2012 during a Pando Daily event in Santa Monica, California. Add this.
See what I'm saying? We've been talking about this a lot longer than I thought we had been talking about this. If he's saying we go back to 2012, where they probably were just showing like drawing specs at that point, I'm ready for this thing to, like, you're looking at a person who don't fly. So this right here is up my alley. So I'm ready for this.
White paper to the video. His vision for this high-speed transportation system included some pretty aspiring features. It would be immune to weather, completely collision-free, twice as fast as a plane, energy efficient, and capable of running around the clock with its own energy storage. It seems quite ambitious, right? But if anyone can make this a reality, it's probably Elon Musk. He came up with the name Hyperloop from the concept of a looped system where the pods travel through a near vacuum tube. The Hyperloop is essentially a futuristic train system that Elon Musk himself describes as a cross between a Concorde, a railgun, and an air hockey table. By 2016, he even suggested that future versions might reach hypersonic speeds. The specifics of making this work, like how to levitate the pod, how to propel it, and what its exact shape should be, are still up for debate. The vision behind the vehicle. Traveling from one place to another in the blink of an eye sounds amazing, but what's the story behind it? How did Elon Musk come up with the Hyperloop concept? Musk's idea for a super-fast alternative to trains involves traveling through a series of low-pressure tubes powered by a vacuum and maglev system. Interestingly, this concept is rooted in studies dating back at least 3 centuries. I bet you didn't know that, huh? One of the earliest visions of something like the Hyperloop came from British inventor George Medhurst in the 18th century. Medhurst was a pioneer in using compressed air for propulsion and even filed a patent in 1799 for a system that would move goods through iron pipes. Fast forward to 1845, when the London and Croydon Railway set up an experimental cargo station, a vacuum between the rails, and the train pushed it forward using atmospheric pressure. In the mid-1860s, the Crystal Palace Atmospheric Railway was set up in South London and operated for a few months. It used a massive 22-foot fan to push the train forward, and for the return trips, the fan's blades would reverse to pull the train back. In his research, Musk gave a nod to US rocket scientist Robert Goddard as one of the first to dream up something like the Hyperloop. Back in 1909, Goddard wrote an article called The Limit of Rapid Transit, where he imagined a train that could whisk passengers from Boston to New York in just 12 minutes. Although it never became a reality, his concept included key elements of the Hyperloop, like levitating pods and a vacuum-sealed tube. After World War II, several attempts were made to develop Hyperloop-like systems. French scientist Jean Bertin's Aerotrain, 1965-1977, used air cushions for propulsion, but ended due to funding issues and Bertin's death. In the 1990s, MIT researchers led by Professor Ernst Fraenkel worked on a vacuum tube train for a 45-minute trip between New York and Boston, but the project was shelved. Elon's Hyperloop idea also has its roots in a 1972 concept called Very High Speed Transit, VHST, which combined magnetic levitation trains with low-pressure tubes. While Musk's Hyperloop builds on some of these original ideas, it's slightly different. He uses tunnels and pods or capsules to get people from point A to point B. Musk has even compared it to those old vacuum tube systems you might see in offices, where documents zip through tubes from one place to another. Design and engineering. Even though Musk first brought up the Hyperloop in 2012, it wasn't until August 2013 that he revealed his initial design. In a detailed 57-page document, he described Hyperloop Alpha.
This represents a new Hyperloop test track record!
A system with enclosed pods for up to 28 people traveling through tubes on air-cushioned skis.
And as soon as I see SpaceX, you know what crosses my mind? We're the guinea pigs. Because if they pull this off and they're successful with this Hyperloop, then you're a step closer to be able to travel at the speed of light in space and trying to get to different planets. So you can research whatever. We're the guinea pigs. We're the lab mice. Because if this is a success, bro, then they'll be able, like I said, travel at astronomical speeds with humans on the vehicles, spacecrafts all around space, and it doesn't take you so many light years or time to get there. That's what I just feel.
The idea was to create a faster, electric alternative to California's high-speed rail, which would connect San Francisco to Los Angeles in just 35 minutes and cost about $6 billion. Musk didn't have the time to take the Hyperloop concept beyond his initial idea, so in 2013, he made it open source, inviting anyone to take a shot at developing it further. Now, the race is on to see who will transform high-speed transport with this revolutionary technology. Enough about the backstory. Let's move on to the more exciting details. Let's now see the proposed designs, aerodynamics, and engineering of the 700 mph vehicle. The Hyperloop design involves a system where sealed capsules, each carrying 28 passengers, travel along a low-pressure tube. These capsules are set to depart every 2 minutes, or as frequently as every 30 seconds during peak times. There's even a larger version of the system that can transport 3 full-sized cars with passengers. The capsules are spaced about 37 kilometers apart and are held in place by air bearings that use compressed air and aerodynamic lift. The tube itself is made of steel and is designed to accommodate travel in both directions by welding 2 tubes together side by side. These tubes are supported by pylons placed every 30 meters, and solar panels are installed on top to provide power to the system. The outer diameter of the tube is 2.29 meters, with a 30 millimeter thickness, while the inner diameter is optimized at 2.23 meters. This setup helps maintain an efficient air cushion around the capsules, reducing air resistance and improving performance. For propulsion, linear accelerators are positioned along the tube to give the capsules a boost. The capsules have a rotor that transfers momentum from these accelerators. Managing the high-speed travel through the tube involves addressing air pressure and friction. While creating a full vacuum is too challenging, a partial vacuum or methods to move air from the front to the back of the pod are used. The pylons are designed to handle thermal expansion and adjustments due to ground settling to ensure a smooth ride. They also need to be spaced and adjusted for safety and stability, with reinforced concrete being the most efficient material for construction.
I ain't gonna lie, the more I look at that thing, the more I'm like, I think I'll give it a year or two, probably 2, maybe 3 to 5 before I get on that thing. Let them work the kinks out a little bit, bro, because yeah, you playing with your life getting on this thing. The more I stare at it, the more nervous I get, and I'd be like, you know what?
AutoCAD was used to plan and design the system precisely, focusing on efficiency and safety and minimizing costs by utilizing air cushion technology and avoiding expensive ground construction. How does it work? To put it in simpler words, one of the biggest challenges with high-speed travel is dealing with friction, both from surfaces and the environment around the moving pod. Instead of traditional wheels, Hyperloop aims to tackle this issue using air bearings, which allow the pod to float on a cushion of air. This is somewhat similar to maglev trains, where electromagnetic levitation eliminates friction between the train and the tracks. This technology allows for super high speeds, such as the 500 kilometers per hour achieved by maglev trains in Japan. For example, Virgin Hyperloop 1 proposes using passive magnetic levitation, where magnets on the trains interact with an aluminum track. This is more cost-effective than active maglev systems that require powered tracks with expensive copper coiling. Musk's Hyperloop takes things further by traveling through low-pressure tubes. The idea is to build tunnels with most of the air removed, reducing air resistance just like how high-altitude flying works. This makes the system much more energy efficient, which is key for any transit system. The original very high-speed transit concept suggested using a complete vacuum, but maintaining that in a tunnel with stations and potential leaks is practically impossible. Instead, Hyperloop plans to lower the air pressure by regularly placing air pumps. While there will still be some air in the tunnels, the design focuses on minimizing its impact. The combination of air bearings and passive maglev is designed to keep the pod floating and reduce the need to push air in front of it. Air will be pumped from the front of the pod to the rear through these suspension cushions, reducing drag. The envisioned tunnels are metal tubes elevated above ground, but they could also be built underground. Musk has even suggested that solar panels installed on top of the tunnels could generate enough electricity to power the entire system. The development process.
Ain't gonna lie, that was pretty smart right there. That's pretty genius right there, bro. But I mean, what do we expect when it comes to Elon, bro? He is setting the bar real high. From robots to the vehicles, this as well, different things. Yeah, he's setting the bar high.
Between 2013 and 2020, a few daring companies took on the challenge of turning Elon Musk's Hyperloop dream into reality. Virgin Hyperloop and Zeleros also jumped into the race to develop the Hyperloop based on Musk's designs. Virgin Hyperloop, which was originally known as Hyperloop Technologies and later Hyperloop One, kicked off its work in May 2016. That's when they successfully completed their first open-air test in North Las Vegas. A few months later, Virgin Hyperloop released its first feasibility study, highlighting the economic and environmental benefits of a potential Hyperloop connection between Helsinki and Stockholm. This connection could reduce travel time between the two Scandinavian capitals to just 28 minutes. In March 2017, they unveiled the first images of their development site in the Nevada desert. It was named DevLoop. This 500-meter-long, 3.3-meter-wide site was the world's only full-scale test facility for Hyperloop at the time. Giegel, who is a key figure at the company, remarked, "Our team of more than 150 engineers, technicians, and fabricators have transformed what was once a barren stretch of desert into the world's first full-scale Hyperloop test site." By July 2017, Virgin Hyperloop had completed its first full system test in a vacuum environment. The vehicle managed to cruise through DevLoop for 5.3 seconds, achieving 2 Gs of acceleration and a speed of 69 mph. Just a month later, they revealed that the Hyperloop had reached speeds 2.7 times faster than the initial test, 2 mph and covering 500 meters of DevLoop. That's pretty impressive. After showcasing their progress globally and conducting passenger application demonstrations, Virgin Hyperloop reached a major milestone. In October 2020, they successfully completed their first passenger test. On the other side of the world, Valencia-based Zeleros Hyperloop began its journey after winning the Best Hyperloop Proposal and Best Hyperloop Propulsion prizes at the 2015 SpaceX Hyperloop Pod Competition. This success marked the start of their efforts to develop the Hyperloop technology. They started working on their prototype in 2016. By June 2019, Zeleros teamed up with Siemens to develop the technology and infrastructure needed for their project. CEO David Pistone highlighted their approach, saying, "Our goal is to reduce infrastructure costs and maintenance, while also incorporating aerodynamic propulsion inside the vehicle, similar to an airplane, but with 100."
Yeah, hearing all that, I don't think we're getting this thing anytime soon. And don't get me wrong, I'm not trying to rush it. I would like to see it, get an opportunity to do it in my lifetime, but I'm not trying to rush it because this you can't play with. It has to be right, or you're gonna have some lives on your hand. You don't want that.
100% electric power. In June 2020, Zeleros secured £7 million in funding, completing their financing stage. Pistone added, "The next steps involve building a complete vehicle, integrating the technologies we've already validated in the lab, and setting up a test track for operational conditions." Another organization focused on developing vacuum transport technology is Eurotube. It was founded in 2017 at ETH Zurich, and then in 2019, it became a Swiss foundation. Eurotube is working on a 3.1 kilometer test tube in Colombey-Muraz, Switzerland, designed to operate at speeds of up to 900 kilometers per hour. On the other hand, the Hyperloop development program is a collaborative effort involving public and private sector partners. It aims at proving and demonstrating the feasibility of Hyperloop technology. It is centered around the European Hyperloop Center in Groningen, which is currently under construction and is set to feature a 420-meter test facility, including a lane switch. Testing is expected to begin this year. Hyperloop Pod Competition. In 2015-16, a Hyperloop Pod Competition drew participation from a mix of student and non-student teams. SpaceX announced the event in June 2015. They sponsored a 1-mile-long test track near their headquarters for the 2016 competition. They made it clear that while they were interested in promoting Hyperloop development, neither SpaceX nor Elon Musk was directly involved in any commercial Hyperloop ventures. By July 2015, over 700 teams had submitted preliminary applications. In November, more than 120 student teams were selected to submit final designs by January 2016. The design weekend held at Texas A&M University in January 2016 saw MIT's team win the overall competition. Delft University won the Pod Innovation Award and second place, while other notable winners included the University of Wisconsin-Madison and Virginia Tech. In January 2017, Delft Hyperloop won the Best Overall Design Prize, and WR Hyperloop from the Technical University of Munich won for Fastest Pod. MIT placed third. The second competition in August 2017 focused on top speed with successful deceleration. War Hyperloop again came on top, reaching 324 km/h. The third competition in July 2018 saw War Hyperloop set a new record with a top speed of 457 km/h. Delft Hyperloop finished second, and EPF Loop from EPFL took third. By August 2019, TUM Hyperloop, previously known as War Hyperloop, won again. They broke their own record with a top speed of 463 km/h. TUM Hyperloop, born out of the Technical University of Munich's winning Hyperloop team in 2019, is in charge of Hyperloop research as of now. The team has won the last 3 competitions and set an impressive world record of 463 km/h, a record that's still unbeaten. Their research program is focused on proving the Hyperloop's technical and economic viability. They're kicking off with a 24-meter demonstrator that will include both a tube and a full-size pod. Once that's up and running, they plan to extend it to 400 meters to test for higher speeds.
Listen, bro, I like the speeds that you're talking about now. 400, 700, stuff like that, bro. Like, you don't have to do much to impress the consumer like me. We don't need that much convincing. The fact that I don't have to get on a plane and I can go from somewhere like Atlanta to New Jersey in an hour. Come on now. That's super worth it.
Locations for this expansion include Taufkirchen, Ottobrunn, or the Oberpfaffenhofen airfield near Munich. As of July 2023, they've started the certification process for operational testing in Ottobrunn. The Hyperloop Association. In December 2022, several major Hyperloop companies, including HART, Hyperloop One, Hyperloop Transport Technologies, Novomo, Swisspod Technologies, Transpod, and Zeleros, joined forces to create the Hyperloop Association. This new group aims to boost the development and expansion of Hyperloop technology and to help shape transportation policies by working closely with governments and regulatory bodies. The association is led by Ben Patek, CEO and co-founder of Novomo. Challenges and setbacks. Elon Musk originally pitched the Hyperloop as a sleek, cost-effective alternative to California's $70 billion high-speed rail project. He argued that Hyperloop could be built for several $1 billion less, though no one's been able to pin down a precise cost for the real-world system. The big question now is who will foot the bill. While some wealthy backers are involved with Hyperloop technologies, others, like Hyperloop Transportation Technologies, are hoping to attract investors for a test track. If these private firms can't secure enough funding, they might need government support, which is a tricky proposition given the political landscape. As for passengers, that's a whole new challenge. Early designs showed sleek pods zipping through transparent tubes, but the reality might look different with metal tubes instead. This could mean enclosed pods, which might be a concern for those prone to motion sickness. Dirk Alborn suggests that in-pod displays might simulate the journey to make it feel more like riding in a car. Overall, while Hyperloop promises to be faster than a jumbo jet, but slower than the Concorde, it remains to be seen how it will affect passengers in practice.
Okay. All right. I like that. Now listen, what I want to know is price point. I want to know price point. Like, we've heard them come out with price points for the robots, 20, 30,000 they're talking about. But this, with all of the things that he can do with it, you know, again, referencing a person like me who don't like planes, You know, and then I foresee them one day putting them. Now I don't know traveling across the big pond on one of those, on one of these, man. But I feel like they're gonna be going from America, USA to Africa, and they have one of those. Yeah, now I'm not ready for that. Not at all.
When it comes to saving time with the Hyperloop, it really depends on where the stations are located in the cities. If the Hyperloop station is a bit out of the way from where you need to go, those extra miles at the beginning and end of your trip might eat into the time savings the Hyperloop promises. Safety is also a huge concern, especially given the high speeds and near vacuum conditions of the tubes. For instance, if a pod stops inside the tube, the system is designed to alert nearby pods and start emergency braking. The spacing between pods would be set up to ensure there's enough room to stop safely. In case of a vacuum leak or rapid depressurization, similar to how aircraft handle such issues, there would be safety protocols in place to manage the situation. The potential for a single point of failure to affect the entire system is another safety concern. With pods traveling at over 500 mph, any stoppage could impact the whole network. Plus, there's the issue of kinetic energy due to the high speeds, which raises safety considerations, especially near populated areas. On top of that, we don't yet know how secure the Hyperloop system will need to be. It might need to meet standards similar to commercial air travel, or could be closer to passenger rail security levels. These security measures and the associated costs will definitely be factors in how competitive the system is. Lastly, no one is sure how the Hyperloop will impact local and national electricity grids. Since there's nothing like it in operation yet, we'd need to estimate and simulate how it might affect power usage and grid stability based on hypothetical scenarios and existing technologies. It's a complex issue that researchers are actively exploring. Impact on transportation. So let's talk about why the Hyperloop could be a game changer in transportation. The main pitch is that it could be faster, safer, more convenient, energy efficient, and potentially cheaper than what we have now. Can you imagine zipping between cities at speeds of up to 700 miles per hour? It's definitely way quicker than cars or trains, and even competitive with airplanes. One of the big wins for Hyperloop is its speed. It's designed to cut down on travel time significantly. No more long waits at airports or dealing with delays. You'd board locally and get moving right away. Plus, the Hyperloop might offer flexible, on-demand departure schedules, so you can travel when you need to, not just when a train or plane has room for you. Another cool feature is the minimal number of stops between your departure and arrival points. The original Hyperloop Alpha concept suggested that for city pairs less than 900 miles apart, it could save the most time compared to other transport options. For longer trips, supersonic planes might still have the edge. Convenience is a big plus too. The system would dispatch small pods around 20 to 30 people very frequently, possibly every 2 minutes or so. Unlike high-speed trains, which run in long connected cars, Hyperloop pods can travel independently or in groups to different destinations. On a bigger scale, if Hyperloop becomes popular, it could reduce traffic congestion. Fewer cars on the road.
Reduce traffic? Hey, you talking to a person that lives in Atlanta. Atlanta, traffic congestion that's Atlanta, bro. It's horrible. And we have huge lane highways, like multiple big highways. Still a lot of traffic here, bro. So hearing that, first stop, Atlanta. Where are some other high traffic areas besides Atlanta? Is Texas one of them? But I know Atlanta is, bro.
Might mean less gridlock, especially on highways and around cities. And with more people opting for Hyperloop over short regional flights, it could ease the pressure on busy airports. So, while Hyperloop is still in the works, it's got some exciting potential to change how we travel. Environmental considerations. The Hyperloop is touted as having a major edge over other transportation methods, thanks to its vacuum environment. The idea is that by reducing aerodynamic drag and using less energy, the Hyperloop could operate more efficiently than cars, trains, or even planes. Virgin Hyperloop One points out that in 2017 alone, flights around the world emitted a staggering 946 million tons of CO2. They believe that replacing flights between 310 and 930 miles with Hyperloop trips could cut those emissions by 58% if the system runs on renewable electricity. Kristen Hammer from Virgin Hyperloop One emphasizes that they aim to power the Hyperloop entirely with clean energy. We don't want to be chugging smoke into the air or causing pollution, she says. It can run on all sorts of sustainable energy. Jacqueline Jenkins, an associate professor at Cleveland State University, argues that any new transit system must be sustainable to justify public funding. She believes that without focusing on renewable energy, the Hyperloop could end up being just a temporary fix rather than a long-term solution. Gabriele Semino from the Technical University of Munich's team says that young engineers today are all about efficiency and sustainability. We're very aware of the issues with burning fossil fuels, he notes. Dirk Alborn, CEO of Hyperloop Transportation Technologies, also has some pretty ambitious plans for integrating renewable energy. He's looking at placing solar panels along the Hyperloop routes and using regenerative braking to generate power. He's even considering wind turbines on unused land. However, some experts, like engineering professor Roger Goodall, argue that solar panels might not generate enough energy to meet the system's needs. The biggest hurdle for the Hyperloop is building the infrastructure, miles of tubes and stations, acquiring land, and navigating through regulations and environmental concerns. The system would involve hollow tubes supported by columns, and the plan is to elevate them to avoid disrupting existing infrastructure. Companies are considering building these
And you should have a button to where the tube separates and opens up in the case of something going wrong. Some kind of way the thing stalls out, can't move. It should be able to just up and people can get out and go to safety until this incident is solved. So that's one thing I think as a safety precaution that they should look into doing.
Elevated tracks in highway medians or alongside railways to minimize environmental impact. Hammer explains that elevating the tubes reduces the need for land and keeps wildlife safe. Musk's Boring Company is also joining the effort. They are planning a tunnel between New York City and Washington, D.C. for either a Hyperloop route or an automatic car-moving system. The company has started on a D.C. building that could serve as a Hyperloop station, though they've been tight-lipped about further details. Noise is another concern, but early tests suggest that Hyperloop pods will be quieter than highways. Finally, the focus is also on making sure the Hyperloop infrastructure doesn't become obsolete. Hammer's team is working on designs that will ensure the system remains viable and doesn't end up like abandoned rail lines. We're not just building this cool thing and forgetting about it, she says. We're designing it to age gracefully. Is it even possible? Handling acceleration can be tricky for people, especially with speed changes and turns. However, it's possible to design a system that minimizes discomfort. Just like commercial jets manage high speeds and turbulence without making most passengers feel ill, the Hyperloop could be engineered for a similarly smooth experience. The big challenge with the Hyperloop is that it's on the ground, not in the sky. Creating a perfectly straight and smooth path for the tube will be a monumental task, but we've tackled similar challenges before.
For this one, we went through all of it and got to pull what we think fits best, because this is somewhere between a car and a train and a plane, and maybe not a spacecraft, but NASA has really good open source docs, so we like to pull from those too.
Like building the Eisenhower interstate system. Mountains, we tunnel through them. Rock walls, we blast them. Bays, we bridge or tunnel under them. Rough terrain, we smooth it out. So yes, it's an ambitious project, but it's definitely within the realm of possibility. The Hyperloop has some major upsides. It promises to be a super-fast mode of travel, cut down on transportation emissions, and let's be honest, it has a serious cool factor. However, there are significant hurdles, especially around safety and costs. The engineering behind the Hyperloop can work. The real question is about our collective willpower. How much do we really want this? The Hyperloop is an exciting idea that could change the way we travel. It aims to move people and cargo quickly and efficiently, much faster than trains or planes. There are big challenges ahead, such as engineering problems, safety concerns, and finding funding. However, the work done so far by companies like Virgin Hyperloop and TUM Hyperloop shows promise. Who knows, it may actually be faster than a Boeing 747 plane. The success of the Hyperloop will depend on solving these issues and our commitment to making it happen. If these challenges are overcome, the Hyperloop could make travel faster, greener, and more convenient. It's a bold idea, but it could truly transform how we get from one place to another. What's your take on Musk's Hyperloop? Do you think we will see it becoming a reality in the near future?